Welcome everyone. And the first talk today is called the ABC of data science. It's not the alphabet, but it's three different types of data science roles: analyst, builder, and consultant. And we have a special guest today, Danny Ma. I am a really big fan of Danny's work. So I try to listen every time he appears somewhere. I try to listen to this, whether it's a podcast episode or stream or whatever. I am a big fan, and you, Danny, are a big source of inspiration for me personally, and I am super happy to have you on the show. So thank you for joining us today, Danny.
Thank you so much for having me, Alexi. This is amazing. Can't
Yes.
wait to talk about the ABCs of data science and maybe
Yeah.
a bit more as well.
But before we do that, before we start, I would like to ask you about your background. And the first thing I want to ask is probably anyone who follows you on LinkedIn knows that you're a meme generating machine. Like I don't know, every time I open my LinkedIn feed, I see a meme from you and it's awesome. And I want to know, like, how do you get inspiration for them? It must be difficult to create so many memes. Like, how do you do that?
So I think the inspiration for my memes mostly come from things that I've experienced in real life. So whether it's or someone doing some dodgy practices with the data science, or they're looking to try and trick some management by telling them something or whatever it is. Like I try and draw on my own experiences to poke a little bit of fun, because everyone knows the funniest memes are always based on truth. So usually I just need to think about things that I've done in the past or I've seen people do incorrectly for the data science, and things just come to my brain.
So you must have seen quite a few things that people did
I
incorrectly, right?
believe so.
That's not something that everyone has experienced. Uh, yeah, and like I don't know if you came here because you saw a post from Danny. You probably saw the video that he made, and this video. I still cannot unsee this video, so I will include link in the comments. But yeah, be careful. Once you look at this image will stay in your head, so it will not go away for a couple of days. Believe me. So how did you learn to do these things? So this is not like an average data scientist, uh, not something that an average data scientist can do.
Yeah, so I'd call it creative video editing, but I think I spent too much time on social media just consuming lots of different content. So I feel that I've developed a strong intuition for what is interesting, or at least what is different. And then I just try and do the video editing to make it happen. I think I'm still very junior when it comes to video editing. I have a friend who actually works for the Australian Broadcasting Company, and he always tells me, "Oh, I should give you some lessons on how to edit properly." I have no idea what I'm doing.
But this is amazing, and of course, like the topic was the Sesame Street, right? So this is like pretty much
Mm.
on topic to our discussion today. And yeah, maybe like on a more serious note, maybe you can tell us about your like apart from this, the most useful skills you have that we already talked about. Uh, would be quite interesting to know what was your career journey so far. So maybe you can tell us a bit about that.
Definitely. So, hi everyone for joining this show. My name is Danny Ma. I would call myself a recovering data scientist after I've spent probably the past 5 years or so working in data science. But I actually started off my career working in data analytics, specifically in campaign analytics. So I was the one in the background trying to identify which customers to send different emails based off their shopping behavior. I did that for 2 years. It was my first job out of university. For university, I took an undergrad in commerce, majoring in actuarial studies. So it's sort of like the maths and the statistics behind the insurance models and the financial models, and also business economics. However, I don't think I actually remember much at all from my university days. So I learned almost everything on the job, instead of when I was at university, too busy partying or doing something crazy. So, yeah, straight after university, I actually, as part of my university, I managed to get a few internships as part of my program working for insurance companies. So this was in the actuarial department where they would essentially have lots of crazy Excel. They used to use a lot of SAS, so statistical analysis software, to do some of the. It's more like reserving modeling and trying to model all the claims and the different things like that within the insurance world. They didn't let me anywhere near it, so it's not like I learned very much when I was doing my internships. But I got exposure to some of the data stuff there. But I also realized that I didn't want to work within the insurance space. I wanted to do something a little bit different, maybe like a non-traditional use of data. And that drew me towards my first role outside of university, which was with Quantium, a data consulting firm within Australia. That was where I did the campaign analytics and retail analytics as well. So think of consumer packaged goods and the different things like that that you can buy in a supermarket. So I did that for 2 years. I kind of stagnated a little bit and I wanted to find a more challenging thing to do. So around, I would say, I can't remember what year it was, but around, let's say a year and a half into my role there, I started waking up every morning at 5 a.m. in the morning to learn Python. Before then, I had very little programming experience. I dabbled with a little bit of R when I was
What
at
did you
university.
use? What did you use as an analyst, like SQL?
Oh yeah, most of it was SQL, Excel.
Uh-huh.
I used SAS again because that was the only thing they gave us
Mhm.
in that company at the time. So I was automating a lot of SQL jobs through whatever tools I could get my hands on. But looking back, my SQL code back then was very, very bad. Like it must have been very like not optimized at all because I had no idea what I was doing. So after I spent my time learning a bit of Python and I asked some of my mentors, okay, what do I do? I don't feel like doing this campaign stuff much longer. So they told me, oh, you should do data science. And
Which year
back
was
then I
it?
had no idea. I had no idea what data science was. So I Googled data science and kind of I wouldn't say I fell in love with it straight away because I didn't know what it was. And I actually started using Kaggle,
Uh-huh.
trying to do different things. I did almost every mistake that every new data scientist would have made on their career and their journey. Um, and then I managed to actually applied for a few data science roles, even though I didn't have any experience. Got rejected for all of them. And then I eventually made it into a role with the bank, so one of Australia's largest banks within the digital area. So I was doing more along the same lines of what I was doing before, but in a different space. So think of all the campaign targeting and looking at the different click funnels and different
Mhm.
things like that on their website.
So same thing,
Um,
but this time with Python, right?
oh, this time I
No.
tried using Python,
Uh-huh.
but it was not very good.
So SQL again.
Mostly SQL.
Okay.
But the thing that helped me bridge into the data science world was we actually had an opportunity to apply data science to some of the problems within that digital space. So one of my first few projects, I actually got to work hand in hand with the data science team. And after that project, I got absorbed into the data science team. So that was around when I became a data scientist by
Mhm.
title only. I
Which
feel that
which year was it?
oh, it must have been 2016, I think.
So
2016 sounds about right.
it's still around that time when companies had no clue what data science is, right?
I think so. I think it had things haven't really changed much in
Yes,
recent years
exactly.
as well. But yeah, I moved into the data science team and I started working on more traditional machine learning projects. So think of all like the customer propensity modeling, looking at time series forecasting. We actually did a lot of experimentation as well. So things about it was still within the campaign and the marketing space, but it was much more rigorous in terms of how you would actually run the experiments and how you examine the results with all the statistical testing and everything up front as well. So the target control groups, but with more rigor. So I spent a lot of time doing that. And then towards the end of my 3 years in the data science team at the bank, I started working more on data assets. So it was more of a exploratory data role, but I would also be implementing the final data products that we were using across the different teams. So one of my big things was to try and capture all the different customer interactions around the bank. So imagine someone takes out some money at an ATM, they use their card to pay for a coffee down the road, then they make a complaint on the website because something happened with their transaction. I'd be able to track all of that at a customer level and kind of draw it on a timeline so people can start analyzing the journeys. But we were also using all of those events essentially to create massive feature sets and machine learning training data. So we're using that quite often. And then soon after I built that product, I got an opportunity to do the same thing, but back at the retailer, but this time doing it on the cloud and doing it with more digital data sources. So think of like Google ads, Facebook ads, Instagram, all of those different things, as well as all their shopping data and whatever else they had at a customer level. So we got to build that in GCP. And it was a really great project because it was quite challenging. And then the team used that data to build multi-touch, multi-channel digital attribution models. But yeah, my last projects were around that space where it was all about combining data, automating machine learning pipelines, and doing everything on the cloud essentially.
Okay, so you basically went, like we will talk about these ABCs a bit later, but you kind of captured at least two of them, right? And well, A and B. But yeah, maybe let's take a bit like a step back and talk. Like I do have a couple of questions about your career journey, but maybe we will go back to that a bit later. And I already see questions in Slido, so we will also get back to them. But we first will talk about like these different types of data scientists, and then we will cover questions. So, so the topic today is the ABC of data science, right? So, what are these ABCs? Like each letter is a role, yeah. And I'm also curious, like how, like was it you who came up with this idea, and if yes, like how did it happen?
So there's a really famous article written by, I forgot the exact name of the person, but I think they were working in the data science team in Airbnb, where they defined like there's two types of data scientists. There's a type A, who is the analyst type, and a type B, who is the building type. Last year, when I was doing my live streams on YouTube as well, I added an extra element of a type C, where it's sort of like a combination of both, but usually more within the management realm. So I think the A and the B, they were already there. I just kind of took them and talked about it a little bit deeper, and then I added the C. I haven't seen other people talk about the C lens of it yet, but we'll see. Someone might claim it, and then I'll just no, it's yours, not mine.
But you can say, okay, I was actually first. Like here's my video. Yeah, but
Hopefully.
let's talk about this A and B and C. What are those?
Okay, so when we think of type A stands for analyst, B stands for builder. So traditionally, when we think of the analyst type, we think of it was similar to the experience which I had when I came in doing a lot of data analysis, being able to look at insights, do data visualization, make some dashboards, and try and figure out what's going on with the data. That's a very large component of data science because we can't really be doing machine learning if we don't know exactly what the problem is that we're solving. So a lot of the upfront work and the investment of time and energy for many of the projects will be definitely done on analyzing data and making sure that we're solving the right problem. So the analyzing type is usually going to come from that data analytics background, maybe with a statistics background, and very research heavy as well. So you might have seen some of the articles where a lot of it was about the origins of the first few data scientists that ever appeared in, I think most of them were in Silicon Valley. And this was like the first time that the term was actually being used was because they brought on PhDs, ex-PhDs, ex-researchers from all the powerful universities like MIT, Stanford, etc., and they put them into their teams in LinkedIn, Facebook, and Google, and they were there to essentially do research and try to figure out exactly where they should invest in money or how they can use the data to build a new product that will help the customer experience. So you ended up getting things like the Facebook knowledge graph, the LinkedIn network graph, and I think like Google PageRank was like one of the original like large scale machine learning products as well. So I think that when we think of the analyst type, they they were that type of people who are the
Mhm.
ones who had to figure out what they were doing and analyze a lot of
Mhm.
things. So they come from a very heavy
Mhm.
research background.
So just to somehow summarize, so as I understood, so first thing is data science type A is not necessarily a data analyst. So this is a slightly different role, right? And then the second thing I heard is like the first data scientist ever who appeared, they were of this type, right? And then the other types kind of followed after that. And yeah, so what kind of background they usually have? Like we mentioned, like PhD. So these are people who are doing research. Um, is it the only type of background they have, or there are some
Mm.
other backgrounds?
I would say that the originals, they were mostly coming from that really strong technical pedigree of having all the training, doing a lot of research, and writing quite a lot of code, essentially. Um, I think over time, because the companies realized that these people were really rare and most of them were very happy to continue doing research instead of moving into the industry, um, I felt, or a lot of the other people who were working with data originally, so your traditional analysts, your quants, maybe some of the database people as well, they started converging onto this role of data scientist. And because most of them came from that analytical background and they were very good with the data, it made perfect sense for them to kind of slot in and start picking up some of the other skills that those advanced PhD researcher types were already using. So this could have been like your Python, your R, all those different languages, which are additional on top of the traditional data analyst skill set of using your SQL, Excel, Tableau,
Mm-hmm.
what have you, data visualization tools. So I think it was most of the background of the people. I think their actual study background didn't matter so much. It was more about their work experience. Of course, you still have people who are doing technical degrees, like the computer science degrees and statistics and mathematical degrees that would also slot into the A type, but they kind of blend in with the B type as well, which I'm sure we'll cover really soon
Mm-hmm.
also.
Yes. So what I heard, the skills are what the skills they need. The type A data scientist, they need first to have um, to know how to program a bit, like use this Python, R, um, have a bit of theoretical background, like know the theory, and usually, like often, these are people who were originally coming from these big universities, famous universities. So they need to know, like, I guess, like theory of machine learning. They need to know how to experiment, need to know statistics, like how to design an experiment, things like
Mm.
this. Is there something else that they also need to know?
I think the analyst types would also have to present a lot of their
Mm-hmm.
insights to the business. So this also ties in with the type C data scientist who kind of specializes in doing that communication piece. But for a lot of the time, when you're doing a lot of analysis, even as a data analyst, you're expected to present back your findings to the business to try and drive some sort of commercial decision or to drive some direction in the project. So I definitely think communication is also very important. But I think, yeah, to round out the skill sets for the type A data scientist, most of it is it's essentially a data analyst plus
Mm-hmm.
additional bits and pieces that
Mm-hmm.
come from research background, a little bit of programming, and
Mm-hmm.
maybe more emphasis on the communication than
Mm-hmm.
before.
Mm-hmm. Yeah, but like analysts are already quite good at this storytelling, like visualization. They just need to add a bit of coding on top of that. And if they don't know theory, they also need to
Mm,
uh, perhaps study more statistics, because usually data analysts already know about a bit of statistics. They just
mm,
need to learn a bit more, right? And um, then also learn a bit of machine learning, right?
mm,
Is this
definitely.
how the learning path? Like, let's say we have a typical data analyst who knows how to write SQL queries, who knows how to create dashboards, who knows how to um, do nice data visualization, and they want to become this type A data scientist. How the learning path for them will look like.
So I can talk about this quite well because that was exactly my path. So I when I started my journey into data science, I could build like do the SQL very badly, do the Excel, do the dashboarding, do a little bit of R, but I had no idea what the other skills were. So a lot of my journey was essentially just trying to figure out what I should learn. Um, Once I had that direction, when I started working with people who were in a data science role, who had data science experiments or experience, and they could guide me on what I should be learning. That was when I saw my own growth and development really like just pick up like a hockey stick. So definitely, I felt that before I had that sort of guidance, I was just kind of fumbling around in the dark, reading a lot of different articles and kind of being stretched everywhere. So you hear like, oh, you need to understand all the theory before you even start doing any programming. And then someone else would say, no, you just go implement the machine learning things and then you pick up the theory. So I
That's what
feel
I
that,
say usually.
yeah, that's what I would say as well. Just go and try a few things. And when you need to learn the theory, you'll know when you need to learn the theory because you have no idea what's going on. So I think that was the same advice given to me
Mhm,
also.
mhm,
So but yeah, I would say for anyone who's currently in a data analyst role or doing work which is not even in analytics, but you're managing databases or you're, um, I wouldn't say a software developer. That comes into the other into the type B. But for anyone who's working with data and they're doing things and visualizing and whatever, there's definitely a path into data science. You just have to be curious and keep working on it and work with good, strong mentors who can give you that level of guidance to push you in the right direction.
mhm. Yeah, so that's so I'm just trying to like how can we formalize this being curious, right? So you can just uh, like let's say you are trying to put a learning plan and then you put Python there, you put machine learning theory there, you put some other things, and then the last point is okay, I have to be curious. And then so how can somebody become curious, or this is something intrinsic that you cannot control?
It's a great question. I think for there's always going to be a spectrum of curiosity. So a lot of people just need to know what's going on to the very nth degree. So I've met people who they wanted to do data science, so they started learning Python, but then they wanted to figure out how the code got translated into some compiler and then got translated into binary code or something crazy like that.
Mhm,
So I think that's probably on the one end of the spectrum where you need to know everything, every single thing. And on the other end of the spectrum, people might just not want to know anything. They just want to accept orders, and they don't take the initiative to kind of push themselves more. Like
mhm,
these people, it's not a bad thing or anything. Like they just prioritize different things for their career,
mhm,
or in life in general. So like my parents are like that in some sense, where they're just not very curious about many things, and they do their 9 to 5, and then they spend time with their family, and that was enough for them. So I think it's very honorable.
mhm,
But everyone lies on the spectrum of curiosity. But the thing about curiosity is that you can literally just tell yourself, I want to be more curious. I want to know this more. So I think for anyone who wants to improve their curiosity and keep learning more different things, you literally just have to make the decision that you want to learn more things.
mhm.
And it's as simple as that. So I feel
So
that, yeah, there's no need to really like formally define the curiosity. I think it's going to be different for everyone, but
mhm.
everyone can do their own version of curiosity.
Yeah, so the way I understood it, correct me if I'm wrong, let's say I'm working with Python code, and maybe this is the other end of spectrum you mentioned, and then I execute a line of code, and then it works, but I start wondering, okay, why it works? And then I start digging deep. Okay, like in scikit-learn, we do this dot fit. What dot fit does, right? And then I go, okay, like I have no idea what this code does. Let me just learn some theory, like how logistic regression works, right? And then I learn that. I come back and see, okay, like how what I just learned, how does it translate to code? And then trying to sort of unwrap this thing. Did I understand correctly?
I think that would be on definitely
One
on
of
the
the,
higher end of
yeah, okay.
on of curiosity. That was exactly how I did it as well.
Mhm.
So the first time I was starting to use the machine learning packages, I actually read the underlying papers within the documentation. But I'm different to many people as well. But I feel that many of my mentors did exactly the same thing, and that's what they told me to do. So for anyone out there, like if you need to learn machine learning theory, there's no better place than to actually read the papers which are implemented by scikit-learn, for example,
Mhm.
or LightGBM or XGBoost. The
Mhm.
papers are all there as part of the documentation, and it's an amazing resource. You can learn a lot just by reading through the math and trying to figure out what's going on.
And I think we're touching slightly the B type of the data scientist because those are more, this is at least my understanding based on what I heard previously from you. Uh, yeah, so maybe let's talk about the B type, the builder. What do they do?
Okay, so I think of the B type as they're essentially software engineers, software developers, just with a very focused realm of data science applications. So, for example, if you're doing a lot of stuff in the cloud and you need to set up the infrastructure, manage all the workflows, work with the data engineering team to make sure all the pipelines are good and solid, maybe you force other members of your data science team to write very clean code so you can write unit tests and functional tests and different things to make sure that the code will run in production. All of these things are hallmark traits of a type B data scientist. Essentially, they're a software engineer,
Mhm.
um, for lack of a better term. I think you can also think of these guys as the new age machine learning engineers as
Mhm.
well, where they're the ones building those systems and the machine learning ops and automated machine learning programs and different things like that. Um, I think one of the key differences between the building type and the analyst type is that the building type always wants to work in the production environment. Like there's almost like a different mindset where
Mhm.
the type A data scientists they're very happy to play around in Jupyter notebooks to just take data from wherever in a CSV file and just explore and see what's there and try to apply some machine learning to it straight away after you figure out what the problem is, of course. But the type B type um, data scientist doesn't really want to do that. They think
Mhm.
of all of that stuff as kind of like a waste of time because they're going to have to refactor it or they're going to have to change it somehow. So it's almost everything. Like people always talk about like technical debt.
Mhm.
There's a famous Google paper of the technical debt of machine learning systems. Um, Maybe we'll try and find a link and throw it up somewhere. But
Yes,
that's a really good one written for type B data scientists. But it's always, I think it's a very good thing to be aware of, even as you're starting in the field, because you can make really bad decisions upfront, which will cost you a lot of money. But if you haven't experienced it before, you will not know how much money it might potentially cost you in the future or cost your company in the future.
Mhm. So I
Um,
took a note. I will add a link, of course. Yeah, but like to me, like you mentioned, technical debt. So basically, type A creates technical debt, and type B fixes it, sort of.
Almost. Sometimes I feel that so the perfect middle ground is where you have a type B data scientist doing the exploration.
Mhm.
That would be amazing because they can kind of put in all the rigor and the infrastructure from day one, and then you
Mhm.
start exploring and testing models in production. Essentially, I think that was through my journey. I managed to get from being the crazy type A data scientist who had no idea what they were doing with the programming in the production environment to working in a production environment with engineers and software engineers and data
Mhm.
engineers and being forced to work how they work and seeing the light in a sense. That's why I sometimes refer to myself as a recovering data scientist because once you get exposure to the way things should be done in a very formal um, software engineering type space, you can't unsee it. Just like the video for my promotion of this talk as well. These things are essentially threshold concepts where someone teaches you something, it's very hard to forget about the way that you now view the world. So yeah, there's a lot of value in becoming a type B data
Mhm.
scientist because When we think of value from machine learning, a lot of it is automated value. It shouldn't be someone has to put in 10 hours of work to get back X amount of dollars. It should be, okay, I built this software, I built this model. It's going to continuously generate me additional revenue. And because you're a good analyst, you'll be able to measure what your incremental value is as well from this model. But if you are a type B data scientist as well, you can build and automate that whole system
Mm-hmm.
and do the measurement for you. And that's, it gives you a bit more buying power as an employee as well. So I think it's really important to cover both skills.
Mm-hmm. But you mentioned that these kind of profiles, they have a quite different mindset, right? So one is more exploratory and the other focuses more on production. Uh, but it's you also mentioned that it's possible, and you are a living proof that it's possible to go from type A to type B. So how can this type A data scientists change their mindset and go to type B? Because it must be quite difficult, right? You're used to playing with Jupyter, executing cells in a different order, and take a look at these Kaggle kernels, right? So they are probably created by type A data scientists. So they have a lot of knowledge, right? But they don't necessarily have this mindset and these engineering skills. So how do they go from being researchers to being engineers?
I feel that there's at least two ways that I can talk about. So one way is as a type A data scientist, you get forced to work on a project in production. So you have no other choice.
Mm-hmm.
And for lack of a better word, you'll have your ass kicked absolutely by whatever's going on because your model won't run, your data is missing, something goes wrong, the package that you are using doesn't exist on some server. Things will go wrong and things will
That's
go
the
wrong
hard way,
horribly
right?
bad. Yeah. So you're learning how to be a type B data scientist the hard way.
Mm-hmm.
Um, I had a little bit of that experience, but I managed to work with people, or at least I reached out to people who knew what they were doing and they told me what to do. So
Mm-hmm.
that was part of my experience at the bank when they didn't have many systems. So a lot of the systems we were building from scratch. So a lot of the auto machine learning, the deployment, like we were some of the first teams to put our models into Docker containers and deploy them somewhere and have like a Git version thing to actually control all the different model versions. So things like that, they sound very, or to some people now, they sound very basic because we have all these crazy new ML ops things coming in to do that for us. But back in the day, we were doing all of that manually.
Okay. Yeah. So you mentioned a couple of things. You mentioned Git. You mentioned Docker. You also mentioned cloud, and I think you used Google Cloud, right? So what are the other things that one need to learn to transition from type A to type B in addition to these things?
Mm. I think
Kubernetes or
the most important thing is probably being, again, like another cliche, like you have to be curious enough to actually
Mhm.
improve your programming skills. Because I feel that a lot of data scientists, because they're using machine learning, they're writing a lot of Python code. It's very easy to almost trick yourself into thinking that you're a good software developer. I know for me, I did that all the time. I thought I was amazing until I worked with people who were actually amazing. And then, so it's always about trying to find, like, there's the saying, like, if you're not the smartest person in the room, then you're in the wrong room, sort of thing, which I don't always believe in. But I feel that there's always something to learn from other people. And if you can learn from the best people out there, that's probably ideal. So you want to almost challenge yourself by always being outside of your comfort zone. The more you spend being the top dog, or you're the one setting all the standards in the team, for example, likely you're not learning as much as you could if you had other people to learn from.
Mhm.
So the one of the major things for me was when I moved from team to team throughout my career, I I just happened to be very lucky to be paired up with someone who was amazing. So when I first joined the bank, I was paired up with someone who was amazing at SQL. So I learned how to write SQL properly. And I still read back my code and I think to myself, what the hell is this? Like, it doesn't make any sense. I do that all the time as well. Like probably the code that I'm writing now, in 6 months, I'll look back at it. I'll just won't know what's going on.
Better not to look at it.
Yeah, better not to look, I think. But I would say so. Git is definitely very important skill. Even for type A data scientists,
Mhm.
like being good with Git, GitHub, Bitbucket, or any of the version control is almost mandatory these days for data science roles. Um, I do think that the cloud is, it's not, I would say it's super popular now already, but in future, just almost everything will move to the cloud. So cloud skills are definitely going to be a thing if they're not already in whichever area people are that they're tuning in from. Um, Literally, we would do everything on the cloud. So, and everything from getting data, we would do it on the cloud because all the databases are on the cloud. And we would just then grab the data from the database and dump it out somewhere on the cloud into storage, into Google storage or different things like that. And then we would spin up a virtual machine on the cloud and you load the data in from the storage area. So everything is quite seamless from that perspective. And a lot of people think that it's there's two camps for people who are learning cloud stuff. It's either, oh, this is too difficult. I need like a DevOps guy to help me do everything. And then there's the other end where you kind of overestimate your ability to do some of the cloud stuff and you can end up costing your company a lot of money. So there's two different spectrums again. But I think in general, the cloud is not too difficult to learn. It's one of those things which you just learn by doing. So the more you expose yourself to these different technologies, the faster you'll be able to pick it up. And the beauty of it is you can learn for free or virtually for free. You can sign up for a Google account or an AWS account or a Microsoft Azure account, and you get like a few $100s in credit, so you can kind of learn.
Mhm.
And there's a lot of different online resources as well.
Mhm. Yeah, but in a way, you kind of got lucky to you had to implement these things, right? And then you also got lucky that there were people around who could help you to actually to learn the skills to master them. But I imagine there are many type A data analysts who do not uh, whose work do not require that, so they are not pushed by the company to do these sort of things, and they also, like, even if they are pushed to do these things, they do not have somebody to talk to. uh,
Hmm.
so these are kind of two things here in one. So maybe let's start with the first one. So if company, so if your work doesn't like, if you don't need to do these kind of things at work, how do you develop these skills? Like, how do you learn cloud? How do you learn Docker? If if all you do is SQL.
This is a challenging one.
Okay.
I feel that so all of these things can be learnt, but the challenge is that it will be difficult without like a very strong incentive for you to learn it.
Mhm.
So maybe we can give some incentives here. Like I feel that in the future, for the data scientists who know cloud computing versus those who don't, um, the ones with cloud computing will always get first round
Mhm.
preference, even if the other person has more experience. And I think that's just going to be a thing, unless you're very well known and you have a very
Mhm.
good reputation. Um, Cloud computing will be a thing. So I think it's when people are trying to push themselves to learn different things, having really good incentive devices or different ideas to force you to learn it at all costs is very good. Another good thing could be you essentially get rid of the lifeboats. So you tell your team, oh, we're moving to Docker,
Mhm.
and then you Dockerize every single job that you have. That would be more extreme. You need to have a lot of trust from your company to actually let you do that, but it's possible as well. The other things you could do could be take it little steps at a time. So at this stage, you might not be very familiar with Docker or with any of the tools that you might want to progress in to become more of a type B data scientist. Uh, Reach out to a few friends who are skilled in that area, who might be working in the same company so they understand the systems, and ask them for advice. I want to do this. How do I do it better? And
Mhm.
then for sure, the engineers will have some idea about how to do things better because engineers usually do. But you'll definitely be able to learn something which you would not have been exposed to by talking to other people within the company.
Mhm.
And if there's no engineers in that company, you can ask a friend or reach out to someone on LinkedIn who might have some more experience on the thing and solicit them for advice.
Mhm. Okay.
But I think, yeah, take things step by step. There's not always a need to cut the lifeboats and aim for the moon all the time, but it's good to have that mindset as well and to always be improving. I think that's more important than aiming for perfection from the beginning.
Mhm. Yeah, and I think you kind of answered the second part of that question, like how to get people to help you. Like if there
Oh,
is no one in the company, like you reach out to people, and there is a question like how do I find a mentor? So this is not an answer, right? So you can reach out to people on LinkedIn, perhaps different communities, right? And maybe other teams in the company can also be an option. And then you also mentioned one thing, like if you at work all you do is SQL, you can try to challenge the status quo, like just approach your management and say, hey, like this is how companies are doing this right now. Please let me give, like, let me spend some time and try to dockerize the thing we have, right? And then this is how you learn, right? But
mm,
like management has to have a lot of trust in you to let you
mm.
do this.
You have to almost like you have to do the time to build up the trust
Mhm.
and your reputation for the business to actually trust you. For one really great example that I've got from one of the people that I've been mentoring on our Slack group. Essentially, he's been working in a role which was advertised as like an analytics role, like a statistical analyst role, but he was ended up doing a lot of reporting work in Excel, which is not great. Um, but he showed some of his managers and his bosses, oh, I've been learning this stuff in the background. He was learning how to do machine learning
Mhm.
to predict churn, predict lapse, predict different things like that. So he recommended, or he said to his management, oh, we have a lot of data about our customers. I might be able to figure out who are the customers who might not be buying with us again. And we can try different things, but I'm not sure if it will work. But if you give me a little bit of time, we can see what happens. And simply because he asked and he was very open about his aspirations to apply more techniques which are very common in the business world, they let him try it and the project was very successful.
Mhm.
So I think different things like that, people just need to be curious, take the initiative and almost own, like put more of their skin on the line. There's like skin in the game or whatever it is, like try to, if there's strong incentives for you to do something, you're more likely to do it.
Mhm. Yes. And so you mentioned persuasion. So this is one of the communication skills, and we talked about communication a bit, that this is a very important part for the type A data scientist. And also there are questions in chat about data storytelling skills, communication in general. And I think it kind of brings us to the type C data scientist. I think for the type C, these skills are more important than for others. So maybe we can talk about this role a bit more. So what is
Definitely.
who is the type C data scientist? What do they do?
So I've been lucky enough to work with a few type Cs where, um, okay, let me rephrase that a little bit. So type C stands for consultant. So they're essentially, when people think of the data scientist as being like, in the past, it used to be the data scientist was the intersection of the programmer, the mathematician, and the business domain expert. So this type C is essentially that person in the middle,
Mhm.
but with very strong consulting skills. So originally, when I was working in data science, the team that I was working in, we were actually part of an internal consultancy model. So we would go out and try and win projects with different parts of the business, and then we would work on the projects, deliver them value, show them how much value we delivered, and then we would get another project with a different part of the business, with a different part of the bank because of the results that we already received. So it was essentially like a traditional consultancy where they do exactly the same thing. They're very heavy in sales. They have people working and delivering the thing. And then they always have really strong stakeholder engagement and communication to make sure that the business problems are being solved adequately with the right solutions.
Mhm.
So in the same way, the type C is essentially um, the ideal type C data scientist would have been an analyst, would have also been a builder, because they'll be able to know what technical decisions and trade-offs they have to make. And also they'll usually type C is either a people leader or a project manager, or they're just very, very good at persuading and talking to business. So, and usually if you're a strong talker, you're more likely to be a people leader anyway. So it all kind of ties in. So usually these type C data scientists, they'll be your general manager of data science or your head of data science, chief data scientist. Um, but however, I feel that there's a precautionary tale around the type C data scientist as well, because it's very, very rare for someone to actually have gone through the type A experience and the type B experience, and then they want to go in and lead projects and lead teams. It's a very, very rare skill set. Not many people want to do all of those things. So there's always incentive for people to make it look like they want to do those things. So probably Alexi smiling because there are many, I wouldn't, there's like type C, let's call it charlatan data scientists. But essentially it would be like a senior leader who doesn't have a lot of the technical experience, but they might be very good with the business. They might be very good at making decisions, but they won't have all the experience to actually make informed decisions themselves. They'll have to rely on their team a lot.
So but they don't have to have this kind of, or maybe like they have to have this kind of skills to call themselves the data science consultants. But in general, for them to be successful, they don't have to have these skills as long as there is somebody of type A and type B data scientists around them who can say, hey, like this is not possible to do. For example, you're selling something that will not work and things like that, right?
Definitely. Maybe my word charlatan is a bit too harsh. Maybe I'll offend a few too many people, but definitely it's more around like the people leader, the business leader, who doesn't have the experience. So there's kind of like different types of like consultants as well. So you can think of them as the true consultants who aren't working very deep in the data, and they're more talking about process to solve problems, trying to work closely with the stakeholders to figure out what the problems are, make sure that their concerns and issues are all addressed. So they're very, very important. But all too often we see that there are some of these leaders who are not very technical, and it's not a bad thing, but there are some people who pretend that they're very technical, but they're not very technical. So it just comes off as a bit charlatanistic.
But yeah, I imagine that it also usually this is the kind of role that pays usually more than the other. Like you have more responsibility, and then this also skill of persuading people. Communication is also something rare among technical people. So this is like a pretty rare person. That's why like this like the pay is higher, and this is well deserved. That's why many people think, okay, I probably want to go down that road. I want to become like a manager or yeah, basically grow myself and do this kind of work more. Um, but it's also again like a change in the mindset, right? So uh, one day you're type B, like building things, and then the second day when you become this type C, like you rarely do hands-on work, right? So this is like quite a shift. So do you know, like maybe you have recommendation for people who think they will like type C work, but they're not sure. Like how can they safely test this and see if this is something for them or not?
Mm. Oh, I haven't thought of this one actually. It's really, really interesting. I think for the people who are looking to who are starting right now, so you're not sure whether you want to be a type A, an analyst, a type B for a software developer slash builder, or a type C for a consultant. Usually, let's say you're coming in as a junior, so you don't have too much work experience, you haven't had too much exposure to technical data analysis or different things like that. I usually recommend them to start off as either an analyst or a builder, depending on their background. So if you have software development skills, definitely try and start off as a builder, because you're already a few steps ahead on the ladder. If you did an analytics degree or anything which has a lot of analysis or Excel or Tableau or anything like that, start off as an analyst because that's where your strengths are. So those two are fine. But when people start thinking about, okay, I'm in it to reach the top, I want to manage business, I want to be the team leader, I want to manage people, I want to make the big project decisions. So usually, if that's your mindset when you're starting, you it's not ideal because you for most people when they get to that level they usually have a ton of experience within the deep technical realms, or they have a lot of experience coming in from the side as well. So let's say I've worked with really successful like general managers of data science and head of data science or whatever, where they've come in from a non-traditional data science background. They might have done something within the data space, like a head of insurance modeling, or they were working in campaign marketing or different things like that. So they were very switched on commercially. So for a few of our viewers, they're probably coming in from that sort of background as well. So they've got quite a few years of experience in a non-related, or either a non-related or a semi-related field to data science, and they're wanting to kind of move into this space. Um, the thing that's most important for the consultant, the type C data scientist, will be a commercial mindset. So that commercial acumen, being able to make decisions, people leadership, being able to talk to businesses, convince leaders to do something, as well as the storytelling piece and all of those persuasion components. They're really important. But I think for anyone who's starting off and you want to end up becoming a type C, um, definitely it's a really great goal to have. But you really want to try and figure out in the short to midterm what you want to focus on, because it's going to be very difficult if you only focus on doing the people skills and the project management and everything to get to the head of data science role. Like it's just not going to happen unless you move around and be a little bit dodgy. It might happen.
Okay, or a bit of luck also will not
Bit
hurt.
of luck also, yeah.
Yeah. So as I understood, like a good background for the type C data scientist is like they either have to be like to have experience working as a type A or type B, or maybe they try to do both, and this is ideal when they become type C. Um, are there other uh, how to say like is there a different type of background that is suitable for this role? For example, product managers, right? Because they already have the skills, they are good communicators, they can tell stories, but they don't necessarily have this exposure to machine learning. Like, can they become a good type C data scientists?
So in the past, I've worked in teams where there was a formal role called data science product manager.
Mm-hmm.
So that would essentially be the product manager for data science products or
Mm-hmm.
data science projects, where there would be machine learning, data analytics, maybe some reporting or different things, but they would have that program lead would be this product owner. So in some sense, it's quite a natural transition. So let's say you're working in a startup, for example, you're dealing something where it's like or maybe a front end facing thing where you're a product manager, product owner, and you manage a lot of the different processes that are going on with the technical teams, but you might not understand what they're doing with the code. In the same way, these data science product managers usually have the same sort of relationship with their teams as well. And it's almost the people who I've seen in that role are almost transplanted out from those teams with traditional product managers, and they're told, okay, manage this data product thing and learn on the fly. So it's definitely possible. Whether you would call them a type C data scientist or not, that would be another point of contention. I feel that for the people who do come from that product management background, and then they start learning some of the data science skills, and they're actually very passionate about learning, like how to use Git or how to use Docker, how to analyze data and visualize in R or different things like that, then I think that's fine. Like for me, it's okay. But I find that for a lot of people moving into that sort of space, it's just not very time efficient for them to learn those other things, because they won't be adding as much value as if they just focused on their role as like a delivery manager. So it really depends on the amount of flexibility you get in different companies, whether they give you that opportunity or not.
Yeah,
But I
it
do think it's very
helps.
useful to learn.
Yeah,
Like, data is the future, right?
yeah, and it helps to speak the same language with data scientists and engineers, right? If they do that, and the, so apart from these three roles, so we talked about analyst, builder, consultant. Like to build a successful product, we need to have other people in the team. So we already talked about the product manager, and then in chat, people mention a data engineer. And this is, by the way, also an interesting question about the data engineer. But yeah, so first maybe, so who else do we need to have on the team in addition to product manager, these three types of data scientist and data engineer? Who else do we need?
Mm. So if we think of like, let's try and build up like the perfect data science
Yeah.
team to deliver something into production. So in the past, I used to think of data scientists as kind of like a SWAT team. Like, you just drop them into a business problem, they figure out what the hell's going on, and then they tell the business what to do, and then they make it happen as well. And then
It's a nice team
eventually
to have.
yeah, it would be perfect. It's like the perfect business team. So if we were to develop that sort of team, we would definitely have, let's start with the engagement first. So you'd have at least one consultant type, or they could be a product manager, but they're very heavy on the engagement with the stakeholders. So they would be like the team lead, essentially, leading the project, leading the team, interacting with the business. So at least one person there. They usually, so in the past, I've seen teams where one person is a business lead. So they'll be very hands on with the business, very strong commercially. They'll have a counterpart, which is the tech lead. So very similar with software engineering teams as well. So you would have a tech lead who's also very good at the business, but very, very good at the engineering. So you would ideally have a tech lead who's very, very good at the data science. Doesn't necessarily have to be very good with the engineering or the DevOps or anything like
Mhm.
that, but they'll be able to talk to those different teams. So you need a connector lead person. So those two are critical. The next two would probably be ideally, you'd have a domain expert. So whether that's a business analyst or a data analyst that works directly in the team, and they'll be talking with the business, because most of the time when you're working on a data project, your team won't be familiar with the data that you need to work with. You need to go out and find out what's going on. You need to actually physically get it from some silo somewhere in the business as well. So you need these people who are really, really strong at SQL, strong with communication, strong with exploration skills to figure out what's going on, read documentation to find out when the data was built, why it was built, what are the processes, what are the ETL stages, all of those
Provided we
things.
have all that, right? All this
Yeah.
information.
Otherwise, you have to like go in and figure out what's going on from the code,
Yeah.
unless they're not doing it with code. They'll be,
Could
so you
happen.
need at least, yeah. So you need at least, so how are we going? So one business lead, one tech lead, one, let's call it like a data lead. So they're very, very good.
Mhm.
Like they probably
Like
work
type C,
as
for
a data
example,
engineer.
or
It would be more like a data engineer who would be more business
Mhm.
side.
Mhm. So data engineer here, like, because there is a question, maybe we can touch on that a bit.
Oh
So
yeah.
data engineer does not fit into any of these letters. So data engineer is not the A, B, or C, right? So this
I
is
think
something.
data engineer would be closest to a B.
Mhm.
So I've actually worked with a lot of data scientists who used to be engineers, and they were very firmly in the type B type data scientists
Mhm.
because that's where their background was. But they were amazing because they were very, very smart. If you told them like, oh, you need to apply this mathematical theory or statistical theory to the problem, they'll just read the source code and be able to implement it almost like for like straight away. So definitely data engineers as data scientists,
Mhm.
very good, very good, very good fit.
Okay, so type B, right?
Yeah, type
Because
B.
Irena answered that she thinks that data engineer is type B, so she's correct.
Correct,
Okay.
100%.
Okay. So we have a team lead,
Oh, back
right?
to our team. So we have,
Yes.
yeah, team lead.
Tech lead.
So the team lead, the tech lead, a data lead,
Mm-hmm.
So they may or may not be a data engineer or a data analyst, or it doesn't really matter, but they're like the domain expert. Then you would have your technical data science team. So you would ideally have at least one analyst type. So they'd be out trying to explore different things. They have a much more strong focus on exploring, but they would work hand in hand with the type B, where the type B will be setting up the infrastructure for them, telling them, okay, if you're going to explore like this, let me figure out what data you need and we'll try and fit it into this thing. So then you can start working in Docker from day one or something like that. The ideal team. So I would say if you have two really strong type A and type B data scientists, you should be sweet. Ideally, you'd have more people learning from them as well. So if they were your senior people, you'd have maybe one or two people underneath them to shadow them and learn. But I think that should be almost enough for like the leanest team that you'd want to try and solve a lot of problems. Maybe you have one more person who is, let's call them like a type A, but is doing more of a data analytics function. So once the data scientists have been building their models and exploring their models and using Docker to do all these things at scale, then the results would pop out. And ideally, they would be analyzing the results with another data scientist who's very focused on doing the measurement piece. Because I think measurement is the thing that's always left out when we deliver projects, like measurement of not just the value of what we're doing, but how much time are we saving? Are we solving the problem properly? What was the previous rate that the problem was being solved? How much uplift are we getting? And what is the cost?
So
Like
business metrics
profit.
basically,
Yeah, business metrics based, but
delivery
being able
metrics.
to translate all of the work that the data science team is doing into time savings and cost savings.
To show business that these people are not just reading papers and
Mm.
having fun, but actually
So
produce
usually,
value.
yeah, I would say the type C data scientist would be perfect in that role as well. So maybe a lot of that measurement goes back to the actual tech lead who's leading these data science teams, because they should be able to translate what their team is doing into dollars. Because I think that's really important when we're thinking about enterprise data science.
Yes, we have quite a few questions, and I think now it's a good time to actually go through these questions and answer them. Um, how anyone without any domain expertise can make a career in data science?
Okay, so there are, let's call them like their whole career is being very good with the technical, but not having to dive deep into the domain expertise because they are consultants. So you could be a very very successful data scientist working in a consulting company where you're moving from one domain to another. So you essentially, you don't necessarily need to be very strong in a single domain, but you have to have skills where you can really skill up quickly in any domain. So that in itself is a very specialized skill. And when we think of like the big three, like McKinsey, Bain, BCG type consultants, that's what they're doing. They get sent one day to a oil field, the next day they're going to a farm for doing agriculture. It's very very broad, and they've started doing data science within those spaces as well. So definitely can be done, but ideally you would be very strong in at least one domain because you have to demonstrate that you can learn about something quickly. And that's probably the best way to do it, is to demonstrate your knowledge in one space.
And that space can be technical space, like
Usually,
okay.
can be, I would say the domain expertise is more around the business domain. I think technical domains can also, you can also have specializations as opposed to the domain expertise. Like let's say Alex is very, very good at cloud computing and deep learning on the cloud, maybe his specialization.
Maybe.
Hopefully. That would also count as a specialization where you don't necessarily need a lot of domain expertise in any specific business domain, as long as you can translate the different problems into your technical specification.
Okay. Or have a product manager or business analyst who
Yes,
can
who can
help
help you.
do that. Okay. And the next question, you probably get it quite often, like how to break into data science as a fresher. And it's like two questions in one, and where and how to apply.
Okay. We can tackle the applying one because I think that's an easier question to do. There are two schools of thought. You either apply for everywhere or you apply for nowhere. So let me let me break this down. If you apply for everywhere, you're essentially going through the public channels. You're going through LinkedIn, like the company website, maybe going through recruiters and different things like that. That's applying everywhere. The flip side of that is if you don't apply anywhere and you literally just only go through referral. So a lot of the it's difficult both ways for people who are breaking into the industry. There's just so much competition and the area is just so hot. So those are the two different ways that you can apply for these roles. But no one really talks about how you get to the stage where you can start applying or even getting referrals. So the most important thing for anyone trying to break into data science would be you essentially need a project portfolio. Um, there's no other way essentially, not in this competition, not in this competitive
Mm-hmm.
environment. It's either if you're lucky enough and your company just happens to have an opening for a data scientist and you're in an adjacent team that you can just kind of they give a chance to you to jump into that data science team like I did, you could be lucky. Very, very rare. Um, Most of the time, people who are coming into data science, the data science roles, they want people with experience. Otherwise, they would just hire someone else with experience.
Mm-hmm.
So the way to combat your lack of experience is to demonstrate what you can do. And one of the only ways that you can demonstrate what you can do in a quantifiable way is to have a project that's public that you can share with the recruiters, with people who might be in the hiring management team, or if you maybe you know someone in the company who knows other people. So this is where your network really comes in. But if you don't have a portfolio to show someone, it doesn't matter if you who you know because they can't vouch for you essentially. So I would definitely say project portfolio with as best programming standards as possible. Try to avoid a lot of the common pitfalls that we see a lot in beginner projects. I can talk about them a lot more, but we'll probably be here for a
I
little
can
while.
imagine what you talk about, like this
Mm,
Jupyter notebook without comments, where you need to execute cells
mm,
in some particular order, just
yep.
dumped where without any
Yeah.
comments, without readme,
Exactly.
without requirements.txt file, things like that, right?
Yeah. Maybe we can do a future session where it's like we'll
Yes,
point out like common mistakes made by beginners on their projects or different
that
things
would be
like that.
interesting. Okay.
Yeah.
And just a follow-up question from me personally, like if somebody wants to break into data science, but they don't know, like, should they go with type A, should they go with type B? Uh, do you think it's easier to go into type A data science job than type B? Or like, or can we even
Mm.
compare them? Can we even say that it's easier, or this is just two separate things?
I think that it will be down to luck and availability of
Mhm.
what's available for you to apply for when you're looking for the first job. So, like, as bad as it sounds, ideally, if you had skills in both, you can apply for both, but not many people are going to have the time investment to actually learn all of the different skills for type A and type B without a lot of work experience. So, usually, what I'd recommend is to um, rely on your background. So, if you have a software engineering background, it'll be much easier for you to
Mhm.
actually make it through as a type B. But there's also there's an alternative side to that as well. So let's say you're a software engineer, or you did computer science as your undergrad. If you decided to go after an analyst role, you'll you'll be more competitive because you're a strong programmer
Mhm.
compared to people who are not a strong programmer. So that's like another perspective to think about it.
Mhm.
So it's not, I wouldn't say that there's a black and white, you should do this or you should do that, but just try and think strategically of how you can use your skills to best compete in that sense.
Mhm.
Unfortunately, it's just how the environment is just so competitive and everyone
Mhm.
is looking for jobs here.
Mhm.
So, but for let's say you're an analyst type and you're hearing this and you're like, oh, damn, I'm not very good at programming. How can I skill up in programming so I can compete against these other people? So that's like the catch 22. So to be able to have a very strong programming background and develop it quickly, Usually those things don't go hand in hand. It takes takes a lot of time to become a good developer. Of course, you can pick up really strong fundamentals and start with really good practices, which always helps. But time on the keyboard is time on the keyboard. Um, Someone with 2 or 3 years more technical experience will always have stronger skills from the beginning compared to someone without any. So it's just the play with the cards that you're dealt, essentially. But you you shouldn't feel discouraged about that. So when we think of the analytics teams and the other things like that, a lot of people want to go straight into a type A data science role. These type A data science roles are actually more challenging than the type B ones
More
because
competitive?
usually I would say you're expected to deliver value sooner.
Uh-huh.
So let's say you're the first data scientist within a company.
Mm-hmm.
You're not going to be a type B data scientist usually because they won't know what they're doing.
Mm-hmm.
So you'll be tasked with, okay, figure out why our sales are down. We have no idea why sales are down, and you've got 3 weeks to do it. Something
Mm-hmm.
like that, something crazy. So a lot of the time when you're doing exploration, usually the best type A data scientists are more senior. They would have had a few more years of experience working with data, and their intuition around the data and the business is usually higher. So I think for people when they're starting off and you're working in an analyst, or you come from an analytics background or not a software engineering background, a data analyst role is not a bad option because you can actually skill up in a lot of the things which we traditionally think of as data science skills. You don't need to learn them on the job. You can learn them on Kaggle, through online courses, through different things like that. The most important thing when you're starting off your career is being close to the data. So the more you can use data using SQL, Tableau, Excel, doesn't really matter. The more time you spend with data, the better. So I think a lot of people really feel stressed about that. Like oh, if I don't get a data scientist role, I don't know what I'm going to do, sort of thing. Like when they're starting their career, um, we shouldn't think like that.
Mm-hmm.
I think if I thought like that when I started my career, I'd probably still be waiting for my first role.
Mm-hmm.
I think a lot of people are probably thinking the same thing too.
Yeah. So, like, short answer, it depends. Depends on your
Mm.
background, right? The long answer is what you just gave.
It would be like depends on your background, your
Interests.
strategy of how you
Uh-huh.
want to do it, and I think it just depends on what your interest is,
Mm-hmm.
how dedicated you are to whatever you want to do.
What is your opinion about bootcamps? Like, is it possible to break into data science, type A or type B data science from a bootcamp?
These days, I think it's going to be rarer. Um, I would say that there's definitely very high quality online training material out there. Like you've got the guys at Super Data Science who are doing some amazing stuff, and they're trying to build out certifications which people can use to validate their skills and use it to get jobs. I think that's really awesome. A lot of the boot camps, I would say, be careful. Of course, they're always going to have really strong marketing. They'll tell you about their star pupils who landed a job in Facebook, Google, Amazon, etc. After they took a 6-week boot camp with no coding experience before. And I would say that those things actually happen as well,
Mm-hmm.
but they are rare. Don't I would not think that that's the average or the mean. They're probably outliers.
Mm-hmm.
Um, and I feel that it's very difficult to teach all of this stuff in 6 weeks. Like you can't really time box learning data science. It should be like a long journey. Like I've been learning data science for who knows how long, like 5 6 years or something. I still don't know what I'm doing. There's always something new to learn. So boot camps are good if you have the time and the money and you're really willing to focus for that 12 weeks or whatever and work your ass off. I think they're really valuable and they're good incentive devices to actually do that. When you do it, do a lot of research, reach out to people who have taken those boot camps to get their feedback, find out how they were doing, if they have alumni that you can reach out to and learn a bit more. like definitely do as much research as you can, and don't dive into something in the spur of the moment and end up paying too much for something that you in the end might regret. So just do as much research as you can.
I think it's a perfect segue to talk about your course, because you mentioned that like it's not like it took you a couple of years to learn that what you know. So it's not possible to put it like to cram everything into 6 weeks or 12 weeks or whatever. Yet you are uh, like I don't want to say you're trying to do this, but like you also see a problem there with bootcamps, with education, with all these amounts of information that we have around. So you decided that you want to create a course. So maybe you can tell us a bit more about the course. So what the course is, for which type of the data scientist it is, and things like that.
Definitely. So I recently launched the Data with Danny virtual data apprenticeship program. So, and as part of that, the first part of that program is my serious SQL course, where I'm trying to essentially train everyone in all of the different skills that I've picked up over the past few years working in SQL. And so my vision for the online course business was, it was actually really interesting because when I started doing all of these things, I actually didn't want to sell a course at all, because I thought that there were ethical issues with charging people money for something which they can learn for free. Like, would people even pay for something that I'm creating, or different things like that, like all the regular doubts that people have also. But in the end, I figured that the way that I learnt my skills was directly through my mentors. It wasn't learning directly from the documentation, or working on, of course, working on learning from the documentation and working on challenging projects. Of course, that helped. But the most important thing was actually to work really closely with a mentor. And this mentor, they might have been an expert in certain areas, but they also had things that they didn't know themselves as well. So it was kind of like a learning journey between the both of us that when we were working together. So in the same way, I wanted to create that same sort of learning experience for not just for data scientists, but for anyone who's starting their data journey. So my belief is that so SQL is going to be a huge thing for when people are going to be accessing data. And then the next few things I wanted to teach was more around data visualization, data manipulation, forecasting, time series, machine learning, all of these things. But the first thing that I chose was to do SQL, because I think that was personally how I learned how to do a lot of the data problem solving, was by using SQL only. And I felt that having strong SQL skills is very important just to understand data. Like it's almost like the natural language of how we use data. Doesn't matter what language, like usually we translate it back to some sort of SQL concept as well. But yeah, I just launched my Serious SQL course. It's in live beta now, so parts of it are still undone. I need to work really hard to actually finish them on time for the real launch. But I had a wait list before, and um, I was I've also launched it on Facebook. Oh no, not on Facebook, on LinkedIn and different places. And the price is currently $29 US. There is a student price out there as well. So if you're a student and you're tuning in, please listen in, or please reach out to me on Slack or send me an email. The email will be support@datawithdanny.com. And I can
And
share
we
you
will include
directly the
this in
link. Yep.
yes.
But the whole thing with the Serious SQL course is to essentially go through as many of the fundamental skills as possible, but also use those skills to solve as close to real life projects as possible based off my experience. So there'll be a lot of technical projects, lots of case studies, and the focus is more on how do we solve different problems. So there's a section which I'm going to be adding more and more interview questions and case studies and different things like that to really help people apply their skills to get the job or to start building their project portfolio as well. So if anyone's interested, please reach out to me.
Yeah, datawithdanny.com, right? Yes.
Datawithdanny.com.
Yes. So there is a question that that is quite related. what is the complete roadmap for becoming a data scientist? And I think if somebody goes to your website, so like Data with Danny is not just this one SQL course, there is like a learning path actually that starts with SQL as a fundamental skill, like you mentioned. Then you also mentioned data visualization, forecasting, machine learning. What else is there in this roadmap? Like what else people should learn to become a data scientist, in your opinion?
So if you're starting from scratch and you have never, oh sorry, ate a bit too much food earlier. If you if you've never used data before, I would recommend SQL first. It's a very natural way to learn how to use data. Then from there, I would say start learning one of the popular programming languages for data science. So this could be R or Python. So the vision for my next course is to essentially teach data visualization, a bit of statistics, forecasting, and data manipulation, but in both languages at the same time, because it's very, very useful to actually be able to do both. And I think the learning experience will be very positive. It will be very challenging, of course, but hopefully we'll make it happen. But I think for the more you know, the more opportunities it really opens up to you. So it's very good to know both. I would say those are the core skills. So it doesn't matter if you do R or Python or both, but you'll definitely need to have strong data visualization, analysis skills, hopefully experimentation as well. So some like A/B testing. How do you define metrics, conversion metrics, and different things like that? And a little bit of forecasting, just enough to know what you need to do for 90% of most of the problems. I think that is the next step. That was my natural step as well when I was going through my journey, working towards a data scientist role. And then after that, we'll probably focus on some of the more traditional machine learning algorithms. So your logistic regression, linear regression, decision trees, random forests, boosted trees,
Mhm.
before we start going into the deep learning. Because I think when we think of the machine learning algorithms and how we do the measurement and how do we do the optimization of all the different hyperparameters, it's much easier when we think of it in the traditional machine learning sense. And with some of these algorithms as well, like my plan is to actually get people to implement it using base Python, for example, or at least using NumPys. Um, and I wanted to also cover maybe Julia as well. So I
Oh,
was hoping
interesting.
the machine learning thing will be in Python and Julia, ideally.
Okay.
That'll be fun. And then after the traditional machine learning, I think that's when the deep learning comes in. So you might want to learn about all the base level of the deep learning, like your neural networks, all the different layers that you could use in your model, some of the new architecture that's coming out. So you've got like transformers are coming out, attention networks. There's a whole lot of stuff and it's always rapidly evolving. So probably by the time I get round to actually making that course, all of what I've said now is probably going to be made redundant. But I think it'll be a very exciting space to work in. But I wouldn't recommend people dive into deep learning straight away from day one. Um, they're very useful, but once you start using them, you shouldn't see them as the hammer, or you shouldn't be a hammer and everything looks like a nail sort of thing.
Yes, thanks, Danny. So I think we're almost uh, like because the next talk will start in 5 minutes. We should be wrapping
Oh,
up.
sure thing.
Yes, and you must be tired talking for one
Oh,
hour and a
no, I'm
half.
fine.
No,
I could,
you're used to this.
I could,
But maybe a
I
quick
could keep
question
talking.
to you. Yeah, a quick question to you because I think I know what you're going to answer. But um, in your opinion, how important it is for a data science position to have a master's degree or a PhD?
Oh, so I would say different data science positions would have different requirements. So if you're, let's say you're working in machine learning research, where you're developing a new algorithm or you're running some clinical tests or something with machine learning or something very research heavy, ideally you'd have a master's or a PhD because you have a lot of experience doing those sorts of things, reading a lot of math and just being able to handle a lot of complexity. Like that's what you're trained for. So I would say anything which is in that realm. So if you think of like the machine learning engineering teams of Amazon, Facebook, Google, any of the big tech companies, that's why they usually prefer people with a master's or a PhD. But for most other roles in the industry, they are not in that realm. Like you wouldn't have to design a whole new layer of a neural network or something
Mhm.
um, to solve some marketing problem or something like that. So I would say that it's not going to be required that you have a master's or a PhD, but it, of course, I think it definitely helps if you've got like a master's in computer science or a master's in mathematics or statistics or something. It'll definitely help. But for people who are making the decision of whether you do further education, it's a trade-off between how much time can you spend doing that education? Are you able to do it part-time, full-time, whilst you're working on a job as well? Like ideally you would, for me, like I haven't got a master's or a PhD, but I've got a lot of industry experience working on lots of different problems. Most of my mentors actually have PhDs or masters, but they
Mhm.
told me instead of doing my further study, they just told me to go read the books that are on the like the course recommended thing. You might learn more than actually doing the degree.
Yeah.
But I would say it's not recommend like not always needed, but it would help for sure.
Mhm. Okay, thanks. I think that is it. Thanks a lot for coming, for sharing all your knowledge, and you have shared a lot during this 1 hour and a half. That was an insane amount of information. So thanks a lot. Thanks everyone for watching and asking questions. We will now have a small break, and Danny, you are free to go. Thanks a lot again.
No worries.
And
Thank you so much for having me on.
yes, thanks. And